Hi, and welcome back to the shop. It's been a while. We left off last time, a good while ago, with our part 7 of a series of videos that was all about jigs and fixtures. And well, that's what we're going to carry on with today. So we're going to be looking at part 8 of that series. And more specifically, we're going to be looking at a new jig. So it'd be good to look at where we were and where we're going. So as we can see, these are the parts that we wanted to produce. Now what we've done up to now is mill the overall shape, and well, we used the shaper to do some of that as well. And we produced this jig, a plate jig basically, to produce these two holes. Now normally I wouldn't go through the trouble of producing a jig like that, but as we've seen in the previous videos, well, I'm pretending that we're producing many of these parts, so it would be economically viable to do this. Now if we were doing thousands and thousands of parts, well, I'd go even a little more serious than this here. But however, this is what we did. Now what's left to do? I want to produce a through hole here that goes all the way through the part. So that's one operation that's going to require another type of drill jig, because this hole is going to be in the tertiary surface. So we won't be able to use a plate jig like this. It'll have to be something else. Maybe an angle plate jig, maybe a milling or a vise jig. We'll see. And well, I want to mill a mirrored flat from this one. So this is one flat that we produce at the very start, and you may be wondering, well, why didn't you just produce the other one at the same time? We could have done that, but since I planned this through before I started cutting anything, I realized that when I do my through hole here, I'll be exiting an angular surface. So drilling into an angular surface or exiting a hole through an angular surface is really not a good situation. So it will be far easier to produce the hole and mill that surface later. And well, that's a good thing, because that will permit us to use or to make, well, for this we're going to use a milling vise or a milling jaw fixture. So we'll be looking at how to produce that and how to use it. And after that, well, we'll be completing our parts. Now, I should have mentioned it, but there is a second reason. It's a secondary reason. It's not the most important reason why we omitted to produce that angular surface opposite the one that already exists. And well, as we mentioned in other videos, foolproofing is important. But I don't think that I mentioned that the fact that these two corners are different makes the foolproofing of my first jig, of my second jig, and of the fixture that I'm going to use to mill that surface a lot easier. If a part is all the same around, well, it's easy to put it in backwards. Now, you say, well, why backwards? Well, when we do our first operation, it wouldn't make much difference because the part is symmetrical. But when we produce the first hole here, or these two holes, everything that comes after that, we have to make sure that it's always in relation to the original references. We can't be flip-flopping a part around. And since I took the time to plan this out ahead of time, well, it dawned on me that if I didn't do that second corner right off the bat, I could use this second corner as, well, a foolproofing part of the part, right? I can use that to make my jigs and my fixtures foolproof. And well, here is our part. We can see that the width of the part is 1 inch 350 thou. The height of the part is 970 thou, and the depth of the part is 625 thousandths of an inch. Now that is important, that last one, because if we look at the hole that we want to produce, we can see that it's a 1/4 inch from the bottom surface or the secondary surface, and it's a 1/4 inch from the primary surface. So if it's a 1/4 inch from the primary surface, it's not on center. And that's something that you really have to watch out for. Just way too often when I was teaching, students would suppose that things are on center because sometimes on a sketch they look like they should be, but they aren't. So this is important. And that's another reason why foolproofing is so important. Now we know what our part looks like and we know what we want to do. Here's the plan. Now I could have used an angle plate fixture. That would have been quite involved. I'm going to fudge something here. It's not fudging in a bad way. It's not a classic jig. And that is, I'm going to make something that resembles the first jig that we produced. Now that jig was to hold a part horizontally with its primary surfaces on the top and bottom. We want to drill a hole here in our tertiary surface, so the part has to be standing on end. And that creates a lot of problems because I have to hold it that way. Now what I'm going to do is I'm going to use this simple plate type jig, and I'm going to turn it vertical by putting it in a milling machine vise. And that's going to do two things. It's going to bring me vertical, and since the vise is accurate, it's going to be accurately vertical. And it's also going to help to demonstrate the fact that locating a part and holding it are two different things. And that's exactly what's going to happen here. This jig will have nothing to do with holding the part. What will hold the part is the vise. What's going to position the part in the right orientation, well, is the jig. And that's why I have to be certain that my part is going to be in contact with its reference surfaces. And from what we saw in the drawing, that's one reference surface and this is the other. And you see that those lines come right up to the lines in the pocket of this jig. However, here's something different, and it's not a screw like we did the last time. What it is a ball and spring sort of clamp, but it doesn't clamp at all. All it does is the spring action pushes the part against the other edge. I have one here and one here. To be designed, I'll have to look and see what I have as far as springs and balls go, because I do have balls. And well, we'll see when we get to that bridge, but I'm not worried that we're going to be able to cross it. And that will give us the possibility of drilling through. Now we have to pop that part in and be able to pop that part out. So what I'm going to do here is I'm going to make a hole in this jig about in the center here, just to give me an opening that I can use to push the part out easily. Now we can't see it here, but we'll just push the jig up against, because I'm going to put the jig in the vise, drill the hole, pull the jig, pop it out, clean it out, put a new part, put it in there. So it's going to clip in, clip out. And since the vise does the holding, because I know you've already thought of this, well, the part's just going to get pushed down. No, that's why the vise is going to hold it once that spring and ball puts it in the right position. So that's what we want to do. Now, we don't have many dimensions here. We have important dimensions, but we don't have stock. So I'll have to go rummage through the scrap box and see what I can find. We want here something, it doesn't have to be fantastic, just mild steel will do just fine. Just a little thing here, I forgot to mention that we do have a foolproof pin here, and that is very important. So it's going to be the same style of foolproofing that we used in the first jig. Now if these holes are offset from one side to the other, and they could be, I don't remember what the drawing was, but I could use those to foolproof my jig, but really this is the simplest way because that surface, that angular surface, is already there. So let's go find our part and we can start producing that jig. So I've rummaged through my scrap box and I've come up with this. It's a piece of mild steel. Actually it's C12L14. It's a free machining steel. That means that it cuts very nicely. It's not grabby, forms really nice chips easily. So this is what we're going to use. It's about the right size. There is no specific size here. I haven't figured any external dimensions, and I'll show you how I know that it's going to be the right size. It's mild cold rolled steel, so the outside dimensions, since it was a bar, are quite good on the primary and secondary surfaces. They're quite nice and square and flat, which is what we want. But our tertiary surfaces here, well, they've been cut on a saw and they're going to need a little work. So we'll square those up to the rest of the block and we're going to do that on our shaper. So how did I determine that this blank part was big enough for the jig that I wanted to produce? Well, we'll take a look here. Here is my blank part, and here's one of the parts that I want to insert into that blank part once it's a jig. So all I have to do really here, and you don't have to get sick with dimensions all the time. What's important here is that the part is bigger than the one that I have to insert into it, and by positioning here I need a good amount of room here to put my ball and spring clamp, and a good amount of room here to put my ball and spring clamp. What's on this side really isn't important as long as it's thick enough to resist whatever the ball and spring will be pushing on here, and that's not very much. And up here all I need is about 1/2 inch, not even, for my drill bushing to be pressed into. Now that tells me that the part will be more than big enough. And it's not so high that it'll give me trouble by sticking out of the vise too much, and that's good also. And there's another thing here that's important, and that is the thickness. As you can see here, my blank part is just slightly thicker than my part to be machined. And once we assemble all of this, I'm going to want my part here to stick out just lightly from the surface. Why lightly? Well, because I'm going to want the vise to push against my part, and that'll push the jig against the vise jaw, and that's how all this is going to be held together when we drill. So this will do the trick. I have to square up the two ends, and we'll do that on the shaper. Just before that, there's something that I probably forgot to mention at one point. I've done so many videos I forget. But here, you see there's a bit of rust on the end there. And another bit of rust here. And that's because it's been rounded off. And that's because this is a rolled bar, and this is the end of that rolled bar. Now normally, professionally, I cut the ends off and just put them straight into the scrap box because there can be problems with an end of bar like this. Not really on free machining steel, but on tool steels of any kind, or even medium carbon steels, there can be micro cracks here that were produced by the end of the bar deforming while it was being rolled, especially if it's a cold roll. So that's why you see these rusty ends. And since this jig is really have nothing to do with tension and everything to do with compression, if there are any small micro cracks that I can't see here, I don't really care. So let's head over to the shaper. Now before we go and set up our part in the shaper, there's something that I'd like to explain. And that is the possible rotation of the part during a cut. Let's suppose that this is my vise jaw, this is my part, and Mrs. Brown is my cutter, and the cutter is coming this way. It could, not likely could, but it could rotate my part. And if it does, well, that would be disastrous. What can we do to resolve that problem? Well, three basic things. There's many things, but three basic ones. Oh, let's say four. First would be to turn the vise 90 degrees. And the cutting action would be going against the jaw. No rotation possible there. But that would make for many, many very short cuts along that surface, and that gets on my nerves. And also, it reduces my chances of getting this really, really square. So I don't like that, so we're not going to do that. Another way would be to set up a stop up here and a stop down there to impede that rotation, or that possible rotation. And that's possible, but you'd have to have threaded holes on the sides of your vise that can accept a stop, an adjustable stop. And well, not all vices have that, so that wouldn't be possible for most people. The fourth thing would be to set the vise at 45 degrees. It would make for a shorter cut, but I'd have to have a long stroke, even though I didn't need all that length of stroke. So that's sort of half and half. It's not perfect and it's not good either. It's somewhere in the middle. But what I'm going to be doing here is I'm going to be using a parallel to redistribute the forces. So in yellow here we have a parallel. Now let's suppose my part is sitting on the parallel and my cutter's coming this way. It's going to want to rotate my part. And if it manages to rotate my part, well, this is going to compress and this is going to have to pull up. And that makes for a situation that's a lot more stable. In other words, this is going to, for the same force of holding the part, this is going to hold it much more positively. And that parallel will give us that. But I hear the neurons flashing here because you remember that I said that the bottom of this part has just been cut on the saw, and it won't be that good. Well, it might be good. You never know, we could get lucky, and if it's sitting on that parallel and I come and indicate this edge, I might find that, hey, everything is grand. More than likely though, the part's going to be leaning one way or the other. What we would like here is for it to be leaning towards the tool. If it's leaning in the other direction, pull the part, turn it around and sit it back down. If it's leaning towards the tool and I tighten the vise down, I don't tighten it final, but I do tighten it reasonably tight. It's going to be leaning this way with a full contact at the bottom. With my positioning hammer, I'm going to come and tap this to just bring it perpendicular to my table with the dial indicator. And when I do that, I'll be compressing here this corner onto the parallel. So it's going to remain in contact. And then I tighten down solid, and if this wants to rotate, well, it will have to compress here and pull up there. And as I just mentioned a few minutes ago, that's a better situation. So let's head over to the machine and set that up. They're all nice and squared up. We're ready to go. And well, in the next video, we'll be drilling and we'll be milling that pocket, and we'll drilling our bushing hole and our spring pin or ball spring holes. And until then, well, have fun, be safe, and happy machining.
So all I ever wanted was a little monkey from you. There you go.